Okay, so I wanted to talk a little bit more about significant figures because there's actually two ways that you need to be concerned about significant figures. All right, the first one that's been talked about so far would be the case where you are the author of the measurement. All right, and what I mean by that is you would be the scientist in the lab with the instrument actually taking the measurement, and you've got to take the measurement and write down what the value of that measurement is. Okay. The other role that you could be in where you need to be concerned about significant figures would be if you're the reader of somebody else's reported measurement. Okay. This would be the case where you're not the scientist in the lab making the measurement. You're actually reading just some bit of text where somebody says 3.87 liters, and you need to be able to make sense of what this number right here means and what it doesn't mean. Okay, so let's talk a little bit more about the difference of these. All right, so first of all, we're going to talk about the way you need to be concerned about something if you are the author. You are actually the person making the measurement and reporting the measurement. Okay, and the thing is, you have the responsibility to report the measurement with enough digits, but not too many. All right, so you need enough digits so that you're accurate, all right, and you do justice to the measurement, but few enough that you're not reporting digits that you're unsure of, all right? And I put this little word completely in parentheses here, and the reason for that is you're allowed to be a little unsure of one of the digits, but there's a limit to that, and I'll show you the example in just a second. So, to illustrate that, here is the rule that we're going to use, all right? The rule is that when you're taking a measurement, you should report all the digits in the measurement that you are sure of, plus one digit, which is going to be the furthest right, that is an estimation, okay? For example, if you were measuring somebody's weight, all right? Obviously, you guys know that, it didn't have to end at that digit. You could have said 124.74973221, keep on going forever. So why would the author decide to chop off the number at this point right here? It has to do with this basic concept that you're going to report all of the digits in the measurement that you're sure are correct, plus one digit, which is an estimation. Okay? Okay. So to illustrate this, I'm going to use this little example right here, all right? And remember, as the author, you have a responsibility to report all of the digits in a measurement that you're sure of, plus one estimation digit, okay? So let's say that we have the task of measuring the length of these bars here, okay? And we've got three different tools that we're going to do it with, okay? First, let's assume we used this little ruler here, second this one here, and third this one right here, okay? So if this is the tool that you had to measure the length, you would have to say, okay, what digits of this measurement am I sure of, okay? So obviously it's bigger than a 4 centimeter mark, but less than the 5 centimeter mark. So you're absolutely positively sure that the first digit is a 4, okay? 4 point, and then after that point, are we sure of the next digit, okay? The thing is, we're not absolutely positively sure, right? I can tell that's a little bit closer to the 5 than to the 4, so just eyeballing this, I would say that's probably around 4.6 or 4.7 centimeters, okay? And the question of which is right or which is wrong, neither is right, neither is wrong, okay? What we've done is applied this concept. We are absolutely positively sure of the first digit in this measurement, and then we're estimating the second one, all right? I would think that if you had said something like 4.2, you're just not very good at estimating a distance between 2 points. But this would be the correct way to measure this, all right? Let's take a look at this example here where the difference is you've got these little tick marks in your ruler, and that allows you to be a little bit more accurate, okay? So, if you take a look at this measurement here, and I'm going to zoom in just a little bit, all right? So, you can tell that this bar is greater than this tick mark, but less than this one right here, all right? So we're absolutely positively sure that the first digit is a 4, okay? And because we've got these tick marks here, we know that the next bar is, the next digit is a 5, all right? We know it's bigger than 5, we know it's less than a 6, all right? So these two digits I'm absolutely sure of, okay? So the rule is we then want to end it with one estimation, okay? So can I make a judgment of about how far between these lines that is? Sure. I would say that's about 5.5. It's about halfway there, so 5 centimeters. All right? Or, somebody else might look at this and say, well, I think that's 60% of the way between that tick mark and that tick mark. And that person might say it's 5.56 centimeters. Okay? Again, either of these would be acceptable. But let's take a look at what we did before. All right? Would it be okay to say 4.6 centimeters for this measurement? Well, the thing about it is, this measurement allows you to be more accurate of it, because you can tell for sure that it's 4.5 something. So let's do one last example right here, and this is a little bit of what you might consider a trick question. What if you had this bar and this is what you were measuring, okay? So you might look at this and say, man, it lands right on the 3. So the answer would be 3 centimeters, okay? And we all know that 3 is mathematically the same thing as 3.0, okay? And so the question is, do we say 3 or do we say 3.0? And the question you have to ask is, could I tell the difference between 3.0 and 3.1, all right, or 3.0 or 3.2, or 2.99 or 3.0? And hopefully you realize that using this type of a ruler right here, the level at which you can make an estimate is at this position here, all right? So for this particular measurement right here, you would say it's 3.00 centimeters, all right? And that's your way of saying that this is the digit at which I'm making an estimation, okay? In contrast to that, if you are the reader of someone else's measurement, the reason you need to be concerned about significant figures is that you should, when you're reading that measurement, let's give that example again, 3.07 centimeters, for example. There's a meaning to the accuracy of this measurement that's given by how many digits are in there, all right? So you should interpret the number of reported digits, otherwise known as significant figures, as an indication of the accuracy of the instrument that the author used when they were making the measurement. All right. So to give you an example of that, let's take a look at this statement right here. All right. Again, you're not the person with the object taking the measurement. You're just reading these words on some paper, all right? It says the length of the bar is 3.86 centimeters, okay? So the thing about being the reader of a measurement is when you read a measurement, the number of digits in the measurement gives you information about the accuracy of the instrument used to make the measurement, okay? So as an example of this, what I want you to think about is which of these devices would you assume the author used to make this measurement, okay? So if they said 3.86 centimeters, would it make more sense that they used this right here as the ruler or this one right here, okay? Remember the concept. The author wants to report all of the digits that they're sure of plus one estimation, okay? Well, let's take a look at this right here. Well, am I absolutely positively sure of the 3? Yeah, you would be. What about the 8? Well, I don't know. Could be an 8, could be a 9. At that point, you're making a judgment call. All right. So take a look at the one below it. All right. It's obvious that the line is, or the bar is longer than this line, but shorter than this one. So you know it's between 3.8 and 3.9, and you can estimate it somewhere in between there. All right. So if you were the reader of this measurement, you would assume that the person taking the measurement used an instrument with an accuracy of this level. All right. You know that they could possibly measure this position right here in the number with complete accuracy, and that one right there would be an estimate. So that would be consistent with using this type of a ruler. Okay, and I'm just using a ruler here as an example because it's a very visual thing to measure. But the same thing could be true of measuring temperature or weight or almost any measurement. Okay. How about this situation right here? If you read instead the length of the bar was 3.8 centimeters, okay? Which of these would you assume that the author used, okay? Well, the thing about this is you could rule this one out here because if this was the instrument that the person used, you can tell it's definitely 3.8 something, all right? These are digits that you are sure of. So you know that the author could have put another digit after that, and if they could measure it, they have a responsibility to do that. All right. The reason that the author would only put a 3.8 there is that would indicate that whatever way they were measuring this, all right, the 3 was the digit that they were sure of, and the 8 was the digit which was an estimation. At that point, could be 3.8, 3.9. Could be 3.7. But this right here would be the one that you would assume that they use.